All right, so we've already talked about how to solve quadratics by factoring. So today we're going to talk about graphing. Go ahead, pause this and write it down. All right, quadratics can have one, two, or no solutions, just depending on if it crosses the x-axis. Remember, solution, zero, root, x-intercept, they all mean the same thing. A parabola or a quadratic that has two solutions will cross the x-axis 2 times. One solution means its vertex is on the x-axis, and no solution means it just never crosses the x-axis. We're always just looking at the x-axis. All right, so here's how we could actually find the solutions of a certain quadratic. So your problem is to find the zeros of this function negative x squared minus 4x minus 4 equals 0. So we're just going to change it. Instead of it equaling 0, we're going to have it equal to y. And you're going to plug this into your calculator. So you're going to go to y equals and type in your quadratic. All right, I've got it in. And up here, I'm going to hit graph. And it's going to graph my quadratic for me. Now, in order for you to be a little more precise, I want you to hit second, go to table, and then you're going to use these values to graph it on your paper. So I graphed my parabola. I know it looks kind of pointy. It's supposed to be a curve. And to find the solution, you just find the one spot where it touches the x-axis. It touches at -2, 0. So -2 is our solution, or you can call it a 0. You can call it a root. It's got a bunch of different names. And remember, that's the same information I could get off the table when y is 0, x is -2. All right, so I've got another example for you to try. 2x squared minus 2 equals 0. We're going to take the 0 and change it into y so that this becomes an equation. I want you to use your calculator to go ahead and graph it. So go ahead and pause the video, graph this on your calculator, and see if you can find your solutions. All right, when we graph 2x squared minus 2, our parabola looks like this. And then I can go to the table. Y is 0 when x is -1. It's also 0 when x is +1. So that means that these are the points where it would cross the x-axis, and -1 and 1 are just going to be my solutions. All it is you're looking for x-intercepts. You can redraw it or you can find it on the table. They're both very, very easy ways. All right, the last little bit of your notes. So far, we've been talking about what are called integral roots, and that just means your roots are integers. They're positive or negative whole numbers, -1 to 7. It becomes a little more difficult when your root or your solution is not a whole number. We call those non-integral roots. That just means you're dealing with a decimal. So we're going to do one of those examples, and I'll show you how to handle that. What we're going to do with our non-integral roots is we're going to put it in the calculator, and then we're going to use our trace function in order to get as close to the x-axis as we can. So here's the example we're going to use. Go ahead and put that in the y equals in your calculator. All right, here's my equation, and then when I graph it, it looks like that. If I go to the table, it does not show me where y equals 0. So what I'm actually going to do is I'm going to go back to my graph, and I'm going to hit this gray button right here that says trace. Now, if I move my arrow keys left and right, I can move up and down the graph. What I'm going to do is I'm going to keep pushing buttons until I get my y as close to 0 as possible. And then I'm going to use that as my estimated root. So I can estimate that my root is about 0.21 because y is very close to 0. And then I'm going to go to the left to the other side. And again, try to get y close to 0. I went too far. 0.2 is really close to 0. So I can estimate a root at about -3.19 or -3.2. So I just redrew my quadratic down here. And I wrote down my estimated roots. These won't be perfect, but they should be close enough for you to see that, okay, yeah, that's about 0.2 would be right. A little past -3, that would be correct. It should get you close enough. And that's how you solve quadratics by graphing.